Consider f of x, g of x, and h of x, where h of x is equal to f of g of x. Given that g of 3 equals 7, g prime of 3 equals 4, and f prime of 7 equals -5, find the gradient of the normal to the curve of h at x is equal to 3. To get the gradient of the normal, we first need to get the gradient of the tangent to the curve h. Now, since we have a composite function here, we will need our chain rule. Okay, so instead of h of x, I'm going to use y to make the notation a little simpler. So the chain rule says that if y is equal to f of g of x, if we let g of x equal to u, then this function now becomes y is equal to, instead of f of g of x, it becomes f of u. And once we put it this way, we can then now get the derivative of f of g of x, or the derivative of y with respect to x. And that will be equal to the derivative of y with respect to u, which is really just the derivative of this. So dy du is actually just f prime of u, multiplied by the derivative of u with respect to x. So it's really just, so the derivative of u with respect to x is really just g prime of x. So now, so again, dy du is just f prime of u, and then du dx is just g prime of x. So f prime of u, now remember that u is g of x. And we are interested in the derivative at h, the derivative of the curve at x is equal to 3. So let's do f prime of g of 3 times g prime of 3. And we actually have g of 3 here. G of 3 is equal to 7. So f prime of 7 times g prime of 3 is 4. And now we are also given f prime of 7. So f prime of 7 is -5 times 4, which is equal to 20. Now this is the slope of the tangent. So the slope of the normal will then be the negative, I'm sorry, this is -20. So the slope of the normal will then be the negative reciprocal of that, which is 1 over 20.